Welcome. Questions that require diagrams. So let's look at our first example here of, and it's brought up over there. It says, given minus 7 tan theta is equal to 24 and theta has a specific restriction, without using a calculator, find the value of this. Now, before I go on with that, as you know, I want to give you a little bit of introduction as to what that entails. So let's see. What I'm going to do is I'm going to say, well, when you get questions that look like this, right? Similar to these questions, another example is a question that says something like, if tan 17 is equal to A, write this in terms of A. Or even a question like this, if sine 33 is equal to this with a restriction on t, well, that restriction is required here, determine sine 237 in terms of t. Or you get something like this, if cos 18 is equal to t, express the following in terms of t. Now, as you can see, all of these require some sort of diagram, but I'll show you exactly how to come up with that. Right, so for now I just want you to familiarize with yourself with looking at the questions. Read this one very, very carefully. Read this question carefully, and also read this one very, very carefully. Now this one and this one and this one over here, they're all similar. Then a more trickier form is of the type that you see over here. So what I'm going to do is I'm going to do the first one with you in a moment. Okay, so getting back to this, right? Like I said, we're going to look at the first one. So what I want to do before I go there is, this is actually just some screenshots that I took. Remember when you had your summary sheet part 1, summary sheet part 2, and summary sheet part 3. Remember this very important rules on the side: never work with angles greater than 90, no negative angles, never work with an angle that's negative, never work with an angle that is greater than 360 degrees. So before I go on to this very first question over here, I'm going to say, let's start with this one that you see over here. When you get this, right? So when we started off the section, we said that the ratios such as sine, let's add some color to our lives, sine, cos, and tan, these all apply to right-angled triangles. They apply to right-angled triangles. They apply to right-angled triangles. So that means in order to solve problems of this form, or problems of the forms that you saw earlier where I showed you these examples, we need to construct right-angled triangles, right? Okay, so to do that, I can say, well, okay, here's a triangle. Okay, here's a triangle, and let's see how we can solve the questions relating to this particular right angle triangle. Now, the very first thing to note here is that tan 17 is equal to A. Tan of 17 is equal to A. Tan 17 degrees is equal to A. No restrictions have been given on the quadrants here. There's no restriction. So what we can say, tan of 17, if this is 17 degrees, remember that this here is 90 minus 17, which will be 73 degrees, right? And then tan of 17 is equal to A. Now, very important to note is that A is exactly the same as A over 1, right? Anything divided by 1 remains itself. So A is the same as A over 1. I'm going to put that over there. And again, tan, their old age, is opposite over the adjacent. So it's going to be A over there, and this is going to be 1 over here. A over 1. Now, how do I find that third side? Well, you can say, Mud, if you, in grade 8 you learned something about Pythagoras. So here we can say that if I say that's the opposite, this is the adjacent, let me call this side x. Then I know that a squared, right, which is the taller side there, a squared, plus this side squared, which is 1 squared, right, the number 1, is equal to x squared. That's actually Pythagoras. Right. And then I can solve for what x must be. X must be the following. X has to be the square root of this whole thing on this side here. X is equal to the square root of a squared plus 1 squared. And there we go. And now I can say that that is x. X is equal to the square root of a squared plus 1 squared. Short side squared plus the other side squared gives me the hypotenuse squared. So the hypotenuse here, which I denoted by x, is equal to root of a squared plus 1 squared. Okay, so now that I have that, they're telling me write sine of 73 over cos 343 in terms of a. So let's do that over here. Okay. 73 over cos 343. 43 degrees. Now sine 73 is an angle that is less than 90 already. Okay, and that angle, seeing that it's less than 90, can I read it off directly from the graph or from the diagram? The answer is yes. There's the 73, and sine of it is the opposite over the hypotenuse. So the opposite of 73, or the side opposite to 73, is this side with the 1 there. So that's going to be 1 divided by this side, which is the square root of a squared plus 1 squared. Now that's in terms of a, because the only unknown there, or the only variable, is a. So what about cos 343? So I'm just going to bring up a new sheet, and I'm going to say cos 343 degrees. This angle is greater than 360, right? This angle is what? Greater than, okay, let's try and improve that there. Greater, there's a better E. Greater than 360 degrees. And our aim is to get the angle less than 90. So we can say want angle less than 90 degrees. Okay, so the way to do that, and if I go back, the way to actually get an angle less than 90 degrees is to use the reduction formula. So that's our plan. That's what we're going to do. We're going to say use reduction formula. How do I use the reduction formula? So okay, let's go back and let's see. If I go back and I can say, well, 343 degrees, where does it lie? If I know that this year is going to be 0 degrees, this year is 90 degrees, this is 180 degrees, and this is 270, so it lies in the fourth quadrant. And cos here is positive, and the reduction formula for the fourth quadrant is 360 minus theta, or theta, right? So let's just bring that back. Yeah, it was here. Sorry, my bad. Let's just bring that back. Where is it? Yeah, we use reduction formulae. So how am I going to do that? I'm going to use the reduction formulae, and I'm going to say, well, okay, the reduction formula in the fourth quadrant is going to be 360 degrees minus theta. And so how I do this now is to say, well, okay, there's 3 steps to using the reduction formulae. I first need to check the quadrant. So what quadrant is this in? It's in the fourth quadrant. So cos is positive. So I'm going to say that's equal to positive cos. Okay, and then I'm going to say it's going to be 360 degrees minus theta. Or positive cos theta, and I have to solve for theta. So how do I do that? I say 343 is equal to 360 degrees minus theta. Therefore theta is equal to 360 degrees minus 343 degrees. And that gives me a solution. 343 subtracted from 360 is 17 degrees. And that's what I'm going to put in here. Cos 343 is the same as 360 minus theta. In this case, we solve for theta, and that has to be 17 degrees. So positive cos 17 degrees. Okay. So if I go one back, this here is going to be apply the reduction formula. 3 steps to doing so. First, check the quadrant. It's in the fourth quadrant. Cos in the fourth quadrant is positive. So it's positive cos of 17 degrees. Right. Now, I'm not done, because the top is equal to 1 over the root a squared plus 1 squared. A little bit small. Divided by cos 17. And cos 17 is going to be this here, adjacent over hypotenuse, and the adjacent over the hypotenuse is equal to a squared. Okay, I tell you what, let's do that last bit over. It's going to be equal to 1 over the square root of a squared plus 1 squared over 1 over the square root of a squared plus 1 squared. And when you have the same thing over the same thing, we can just conclude that the answer is 1. Now that looks very similar to saying it's A over A, or B over B, or cow over cow, or chicken over chicken. And if I have 1 over root A squared plus 1 squared over 1 over that exact same thing, then the solution is 1. Okay, so let's try another one quickly. Now this one looks a little bit trickier, because it says if sine 33 is equal to this thing. Now, for starters, what we can say is, well, sine of 33 degrees is equal to the square root of 1 minus t squared, and 1 minus t squared is the same as 1 minus t squared divided by 1. Now when we talk about sine, we can suppose that this is referring to the opposite length across from 33 degrees, and this refers to the value of the hypotenuse. Okay. Now, if I were to construct my triangle, if I do it over there, there's my triangle. 33 degrees will be over here. This will be a right angle because sine applies to right angle triangles. And on this side I got 90 minus 33. Well, 90 minus 30 gives me 60, and 60 minus 3 is going to give me 57 degrees. Right. Now, given that I already have things here, I've got sine of 33 is going to be the opposite over hypotenuse. So the hypotenuse has a value of 1. And the opposite length here is going to be the square root of 1 minus t squared. Now again, if we were to use Pythagoras, right? Let's quickly think of a right angle triangle, very roughly over there. Pythagoras says, so apologies, we just had a call coming in studio there. They didn't put the phones on silent for some reason. Anyway, if this is A and this is B and this is C, Pythagoras says that this side squared plus the other side squared is equal to this side squared over here is equal to C squared. Now using that relationship, if I know that this side here, B, is equal to the square root of 1 minus T squared, and I know that C is equal to 1, what is the value of A? Well, simply A is just A squared plus B squared is equal to C squared for this Pythagorean relationship over here. And I get the following. I can say, well, A is what I want. So I have A squared, and that's equal to C squared minus B squared. But C squared is just 1 squared, right? Minus, what is the value of B squared? Well, B is going to be the square root of 1 minus T squared squared. And that's going to give me 1 squared, which is just 1, minus the root and the square. They cancel with one another. And that's going to give me plus t squared when I multiply that in that way. Okay, and there we go. So this value is, this cancels out and I just get t squared. A squared is equal to t squared, therefore A is equal to t. Now if I take that back to the previous slide over here, I can say, well, A is the side over here that has to be t. This length over here must be t. Okay, I'm just going to write, let me just draw an arrow and let me just call it t. There, little t in the bottom corner. Okay, so let's do this. Solve for sine 2, and oh yes, this restriction, we don't really need to pay much attention to it, but the reason it's there is because this is a square root, right? And a root is only defined if it's greater than 0. So this is saying that t needs to be between 0 and 1 for this thing to be valid. Okay, so let us solve for sine 237. Now we ask ourselves, is this angle greater than 360 degrees? The answer is no, so it's within 360. Now once it's within 360, we can apply the reduction formulae. Right. If it's greater than 90, we need to apply reduction formulae. So I'm going to say sine 237 degrees is equal to, let's see, where does 237 lie? Is it in the first, second, third, or fourth quadrant? Look at your reference sheet, right? So I've got my reference sheet over here. 237 is in the third quadrant. And in that quadrant, sine is negative. So it becomes negative sine. Then the reduction formula for the third quadrant says 180 plus theta must equal to sine 237 degrees. So what is now the value of theta that I solve goes here. And I say that is equal to 237 minus 180 degrees. And what does that give me? 237 minus 180 is going to give me 57 degrees. Right. So negative, and what's the value of sine 57? Well, sine 57 is going to be the opposite divided by the hypotenuse. That's t over 1, and therefore my solution is just negative t. Okay, so I'm going to leave you with one more for you to try on your own. In fact, I'm going to go over the solution to the tricky question that we just introduced now. and then I will leave you with one more.